looking at 8-4. This is our day and only day. Little reminder, tomorrow is Friday. We're going to be working on 8-4 today, and we have a worksheet for word problems tomorrow after your quiz. You have a quiz tomorrow in sections 8-1, 2, and 3. Okay, so after notes today, I strongly recommend that you reread your 8-1, 8-2, 8-3 note stuff. Look it over, make sure you get ready for that quiz. And then tomorrow, we'll correct the 8-4 assignment, talk about maybe a couple other things if you guys had any questions coming up from that rereading, and we got it going. Okay, so make sure you're getting it done. I care about the fact that you have questions today. At the time of a quiz, it's going to sound really cold, but I really don't care, okay? Because you had opportunity to prepare, and if you've been here, you got to be ready to take it, okay? So you've got to make sure that you know it's about today being ready, and when you come in to take the quiz, big game day, nobody cares you're not prepared. You got to do it because you were told that's what you got to get done. So make sure you're getting ready for that. Yeah. Is our test next week? Yes, our test is next week. It's on Friday. Okay. Any other questions? Okay. So and the quiz is paper. I want to see what's going on. You got to manipulate. You got to show work. Okay. Angle of elevation is what we're looking at today, and angle depression. So I want you to think about lines of sight. You're going to look straight out. Okay. And that is a line of sight. It's generally horizontal with the ground. Okay. If you have level ground, your line of sight's horizontal with it, okay? And it's parallel to that level ground. So when you're looking out straight, if you look above your line of sight, that's called an angle of elevation. If you're looking out straight and you look below that line of sight, that's called an angle of depression, okay? So knowing that is a necessity to help us with these next few things. And because of that, there's connection. We got to think about parallel lines and transversal. The angle of elevation and depression are alternate interior angles of that, and those are the same. Okay, they're the same value. So in the same situation, if I had someone on top of a ladder, on top of a mountain or anything, this person's up here, and this is their angle of depression, maybe I should say, put that person down here so because it's even with their eye. And then I have another person here looking up, even with their eye, okay? I am actually talking about the elevation, angle of elevation from the person, the red person, and the angle of depression, the black person there, that I have my black and red stick people, okay? They're the same angles because those angles are created from their horizontal down, or their horizontal up. So the horizontal down is an angle of depression. The horizontal up is an angle of elevation. Are there any questions about that? Now it's just us applying it. Okay, so now let's talk about, I've got my bird, okay, up there. It's at angle 1. And I'm saying, hey, from angle 1, is it an angle of depression or elevation? And it's in respect to the bird. The bird has angle 1, its line of sight's horizontal, but it's looking down at the person in the balloon. So that's an angle of depression, and it's bird to balloon, okay? So my next thing is the person in the balloon has two angles, really. Going straight out is horizontal, right? And we have an angle of elevation in angle 2 because the person in balloon's looking up from the horizontal, up from their line of sight at the bird. So it's angle of elevation, and they're looking from the balloon to bird. Okay, does that make sense how I'm setting these up? Now what I'd like you to do is answer the last two. And let's pretend that this green person, my green person, is just hanging out on the bottom of the hillside or the base of the mountain, you know, got an angle of elevation going on there. Just thought I'd tell you. Go ahead and fill in the other two, 3 and 4. Look at angle 3, look at angle 4. Make a determination. It's either angle of elevation or angle of depression. So we're looking at this. I got depression for angle 3 from the balloon to the mountain base, and elevation from the mountain base back up to the balloon. Are there any questions about elevation or depression? Now I have an apology to make. The notes were destroyed somehow in when I put them in there. There are a lot of typos. There's a lot of adjustments we got to make, but we'll muster through. So I apologize for this. I have no idea what I did, but I made corrections. And I did something else. I did a couple other things and oh, I got to print that out, and I printed it out without checking what changes I made to those corrections because I thought everything's perfect. Yeah, not so much. 2 and 3 weren't affected, but 4, 5, and 6, holy cats, they were really affected. So how high off the ground is a plane? 10,000 feet from the runway, okay? And what I want to do here, we're just going to make a picture here. How high off the ground is a plane? So I've got a plane. It's 10,000 feet from the runway. We're going to go 10,000 feet like that. It's from the runway. My gut runway. Okay? 10,000 feet from the runway. And it's got an angle of elevation from the ground, 12 degrees. 12 degrees, angle of elevation from the ground. 10,000 feet from the runway, right? So now I'm looking at this and I go, all right, they want to find out how high the plane is. And this is in feet, so we're all good. So we've got to, once we get a little picture, we've got to be able to look at it a couple times, fill in our stuff, and you notice how high is off the ground is a plane, so that's X. 10,000 feet from the runway, distance from the plane to the runway, at an angle of elevation of 12 degrees from the end of the runway of the plane. Okay, are you okay with this? It's 10,000 feet away, so. And then I've got some people going, oh, it's 10,000 feet. I mean, it's less than 2 miles. Okay, but how high is the plane? At 12 degrees here. Okay, so now I've got opposite hypotenuse, right? So I've got the sine of 12 degrees is equal to the opposite over hypotenuse. Now, 10,000 sine of 12 is equal to X. Let's grab ourselves a calculator. I suppose I should have come equipped with my calculator. And put in our 12,000, 10,000 times sine of 12 to find 2,079. So I'm 2,079 feet above the ground. Are you okay with that? Okay. So 2,079 feet above the ground. You're on to number 3. You got your own. I gave you the picture. Go for it. Read the question, look at the picture, check it out. Yes, the ski hill's a little less than 3 miles long. It is not in Minnesota. A little side note for the guys. When you ask your girlfriend or fiance, hey, can you ski? Why don't you come on this trip with us? Go skiing with them first. That 3-mile trip might be 10-time wipeout. You know, here in Minnesota, you fell every other time, but it's pretty brutal on a body if they're not really avid skiers. I just took it as, oh, you can ski. All right, great. Okay. That's a story later, but just a little FYI for y'all. That's all right. She's forgiven me now. It's been 20 years. we're looking at this. Find the elevation of a ski hill. Okay, we're doing the same thing. I've got here 25 degree. Remember, my angle of elevation and angle of depression would be the same if I needed that. I've got opposite hypotenuse. So I'm checking this thing out. I've got the sine of 25 is equal to x over 15,000. Don't forget to finish all the zeros on this. Okay. Multiply by 15,000 on both sides. So I got 15,000 sine of 25 is going to give me 6,339.27 feet for x, my elevation of my ski hill. I think I put that in there. So that's my ski hill elevation. Are you okay with what we're finding? Are we good? We're bad? Okay. We're all right. All right. Now I want you to do something that's really funny for elementary school kids because they just started learning this, and I haven't shown my son this. I've got to do that to him today. But point at your fingers. You're going to point your finger at your head and abbreviate mountain. MT, right? Think about it. MT. Anyways, all right. Thanks. It's not true. You guys are all very full there. Okay. A lot of brains in those heads. Okay, for most of you. Cookies in your head. All right, so here's the deal. We're looking at problem 4. And I made this change, and I'll be honest, I made this change, and I'm really glad I'm making you write this in the way I'm going to make you write this in, because it makes the problem much different, and it should be something you should pay attention to. You should pay attention to, because this is a type of problem Bloom would put on a test. Okay, in almost the same way. So John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. John's eyes are 5 feet above the ground. The angle of elevation to the top of the tree is 33 degrees. Now I've got some people thinking, why does it matter that John's eyes are 5 feet above the ground? Well, remember, I've got John looking up, and he's got this angle of elevation, and I have no idea why we have that in here. So we'll put it up there. John's looking up, and we've got this angle of elevation of 33 degrees. He is 100 feet from the base of the tree. So we're going to find x, but when we do, we will miss out on 5 feet because his eyes are 5 feet above the ground. Does that make sense? So we have to make sure that we bring that back in after we solve for x. Okay, remember we go from our horizontal sight line up. So we're missing out on the stuff between his horizontal sight line down. And we have to add that back in. So in this problem, I'm looking at this, and we've got the opposite over hypotenuse. So we got a tangent of 33 equals x over 100. Okay. So we get this written down. We're all real happy about it. We multiply by 100, and we find out that that's 64.94. And I've got students that'll just run to the final answer, and that'll be there. Might even be about 65, because we're talking about the height of a tree, and 0.06 on the height. That's going to be taken care of like on a really good sunny day. It's probably going to cover that. So we'll talk about 65 feet tall, right? So we're looking at this, and I've got 65 feet, but I have to add the other 5 feet. So I got the 64.94 plus the 5 feet, the distance from his eyes to the ground, because it was 5 feet above the ground. And now I can say the tree is 69.94, so approximately 70 feet tall. By the way, that single hash mark above means feet. Okay, English marking. Okay, any questions about that? Now, how will I have questions worded so I don't have to consider the person's eye level? I won't give you that information. Or I'll say the angle with the ground. okay? Or I'll call it the angle of depression, okay, as we're talking about it. So pay attention to those hints as you read a problem. You guys have problem 5, give it a try. A building is 50 feet high. At a distance away from the building, an observer notices that the angle of elevation from the top of the building to the ground is 41 degrees. How far is the observer from the base of the building? So we're looking at this, and maybe you had to read it a couple times. Okay, that's okay. Maybe you started with your sketch and then you reread it and then you've changed your sketch. That's okay. The expectation is that you're reading 5 to 7 times every time you do one of these problems. Okay, so now I've got a building that's 50 feet high. And remember, it's 50 feet, so it's 50 on this side and this side. At a distance away from the building, an observer notices the angle of elevation. An observer notices the angle of elevation from the building to the ground. Okay, so this is on the ground, is 41 degrees. How far is the observer from the base of the building? How far is the observer from the base of the building? Well, now I've got this set up. I've got opposite, adjacent, right? So I'm totally talking about a tangent situation when I get this going. So I'm at this point, I multiplied by x on both sides, and I'm going to divide by tangent of 41. So 50 divided by tangent of 41 is the value that I'm working with, and it's 50.52. Now, at this point, I'm having some students asking me, Bloom, what's the deal? Sometimes you round it, sometimes you don't. Why? Based on the directions, I'll round it to the 10th, the 100th, or to the nearest. Okay, the previous problem, I have my answer as 69.94, and I put in, well, it's about 70 feet. Okay, because it was something that was growing. By the time I'm finished writing the problem, it's grown at least at 0.06 of a foot. Okay, if I break a foot up in the hundreds, it's just about that much. Okay, so keep in mind, you'll be told in the problem or in the directions. So make sure you're reading all the words in that test. Okay. But if you're not told, my habit always is give it out to the 100th, the penny. Because if I pay for something, I'm always waiting around for the clerk to give me my penny back, right? Whatever pennies it are. Because I got a jar at home I'm filling up every day, right? It's like a goal. Okay, so I'm going to put my extra change in that jar. And I want to make sure I get it. So if I've never told you, just do it to the 100th. If they tell you, then do it accordingly, okay? Now, we got problem 6. Give that one a try. I think that one's pretty straight up, so I'm going to let that roll. You guys go ahead and try problem 6 on your own. Try problem 6. Am I asking you to find a distance here? What am I asking you to find? An angle. Okay, so we're trying to find an angle, and we learned the undos yesterday. So I got my picture, and I drew it this way too, because I want you to see that if I drew it like this, working with my angle of depression, angle of elevation, same thing. This angle is the same. By the way, I put this theta in there. Theta is a variable, okay? It's a Greek variable. It's just not a letter X or Y. It just represents a value. That's it, okay? So what I'm looking at here is what is the angle of depression from the airplane? So I have this angle of depression. I flipped it around because everybody's used to seeing the picture this way. Because remember, these are alternate interiors. These are parallel here. I'm pointing to these. These are parallel. lines coming out from the plane and going along the ground, those lines of sight. And I've got these alternate interiors. They're the same. Well, I don't care which triangle I'm working with. I either work with this triangle where I got opposite and adjacent, or I'm working with this triangle where I got opposite and I got adjacent. Either way, it's tangent of 2/5. Okay? Both have the same alternate interior, so I've got a tangent inverse of 2/5. And that's my theta. That's the angle I'm going to find. So inverse tangent of 2/5, remember second tan, and we're talking about 21.8 degrees. Are you okay with that? So 21.8. So what's the angle of depression? My angle of depression is 21.8 degrees. Are we doing okay? Your turn, last one, 7. Make the picture, reread it, fix the picture, reread it, answer the question. And that's pretty much the order you got to do. I always get students going up there, yeah, I don't get this, Bloom. I go, how many times do I read it? Once. I can tell their time. They're like 3 times. Okay, 5 to 7 is not unheard of. It's okay. Okay, go ahead and just read it a few times. By the way, the thing that you need on this one, write this in, you need to have 35 degrees. That's degrees, it's not a length, it's the angle that we're working with. Okay, the bird has from looking down on the lamppost, thinking that it might want to do a number on the person below. So hopefully your picture kind of looks something like that. And you got X, and the bird's distance to the person is 25 feet, and that's gone along the hypotenuse there. And then we make the decision on finding how high the lamppost is. Now, because it's an angle of depression, okay, the observer standing away from the lamppost is 35 degrees. The angle of depression, remember that 35 and this 35 are the same, okay, which means this triangle and the other triangle that's created to find the height of the lamppost is the same. So I don't care which orientation you have for your triangle, we're still looking for how high up the bird is sitting. And because the distance of this lamppost is so much, that little itty bitty bird isn't going to be that big of a deal. It's not like it's a, you know, California condor or anything like that, okay? So I'm looking at setting this up. I got sine of 35, okay? Because this is 25 degrees, or 25 with my units as I'm looking down, okay? Questions about what I'm doing and how I set things up? Are we doing okay? Now, just multiply by 25, pop it in my calculator, and find out I got 14.34. Then, word problem, word answer, the height of the lamppost is about 14.34 meters. Are there questions regarding these? Making sense? Okay, so here's the deal. Today you'll be asked to read situations and set up the problems yourself, okay? Tomorrow, you'll have the quiz. It's a 7-1 to 7-3. I strongly recommend you reread your notes, okay, in preparation for your quiz. So make sure you're ready. If you have questions, I can answer those questions right before the quiz, but we have about 5-7 minutes to answer questions. So today, during work time, is your best time to reread your notes and ask questions during work time. Then, After your quiz, you'll do a word problem front and back that covers questions from 8-3, okay? And we'll be done for the weekend with nothing from me if you do the stuff you're supposed to do, okay? That's all there is to it. Okay, so let's make sure that that's the case. Those folks at home, be prepared for that quiz tomorrow. Talk to you soon.